Question number 15 just came from 14. Question number 15. A student wants to find the height of a tree. He places a mirror between himself and the tree, sounds familiar class, and creates the diagram below. Using his sketch, find the height of the tree. Well, we've got two similar triangles created. We know that because they have a right angle that's congruent, and this angle is congruent by the law of reflection. So all we got to do is find our proportion that's allowed. Well, we know that ED, which is the height of the tree, goes together with AB, which is the height of the students. Go back to our original triangle. This is triangle 1, this is triangle 2. We go back to triangle 1. We've got DC on the bottom, and that goes together with CB from the other triangle. So there is our proportion. Let's go ahead and fill out what we know. ED is our unknown. That's going to be our X. AB is 67 equals DC is 158. CB is 32. Remember class, we're matching up corresponding sides. We know that the vertical sides are corresponding, the horizontal sides are corresponding, and then the hypotenuses are corresponding as well, but we don't know the measures of those. So there's our ratio. Let's go ahead and work this out. X times 32 is 32x. 67 times 158 is 10,586. Let's divide both sides by 32. And you've got x not equal to, it's going to be an approximate answer. X is approximately 330.8. So our answer is going to be in a sentence. Here's our sentence. The height of the tree is 330.8. Our unit of measure is inches. 330.8 inches. That's number 15. Let's see if we can squeeze in 16. Alright, 16. Dilate the shape on the graph by a scale factor of 1 to 2 and label the image vertices using prime notation, and we're going to assume that the center of dilation is the origin, or 0, 0. Now, first thing I'm going to do, class, is change my scale factor from 1 to 2 to a fraction. Now I see my scale factor is 1 over 2, and that means it's a reduction. I'm going to make a smaller image than my pre-image. Now, just like you can double your squares when you dilate something by a scale factor greater than 1, if you're dilating by a scale factor of 2, you double. By 3, you triple. By 4 times, you go 4 times as far away. For a scale factor of 1/2, you cut it in half. So let's take a look at doing W. 1, 2, 3, 4, 5, 6, and 1, 2. So W is at 6, 2. We cut that in half. 6 divided by 2 is 3. 2 divided by 2 is 1. So 1, 2, 3, 1. There is our new W prime. Let's take a look at Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. It's going to be at 5, 1. 1, 2, 3, 4, 5, 1. There is our Y prime. And now we got to get Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So 10, 8 becomes 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. I think that's 4. Let's make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yep. And there is Z prime. So you can see, class, that I took every coordinate and I cut it in half. Each coordinate in half because our scale factor is 1/2. Let's go ahead and connect those points together and make our new triangle. That's not nearly thick enough. Try that. So there's our first line. Here's our second line. And here's our last one. I'll do the best I can to draw straight lines for you guys. That's close enough. And there we go. There is our shape dilated by a scale factor of 1/2. All right, let's do number 17. Dilate the shape on the graph by a scale factor of 3:1. So now our scale factor is 3/1. Well, that's an enlargement. And label the image vertices using prime notation. All right, so now we're going to go 3 times as far away from the center of dilation, which is the origin. Let's do S first. 1, 2, 3, 1. So I'm going to go 1, 2, 3, 1. There's a scale factor of 2. 1, 2, 3, 1. There's a scale factor of 3. We are 3 times away from our center of dilation. Let's do W. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. There's twice as far away. 1, 2, 3. 1, 2, 3. There is 3 times as far away. And there is our W prime. Okay, T is 1, 2, 1, 2, 3. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. So there is our T prime. Let's go ahead and connect those together. See how that looks. Here's our first line. Here's our second line. Oops, I'll try to get that lined up a little better. And that's good enough. And here's our third line. Now, if you want to do a quick math check on that, take a look. TW is 1 unit. T prime W prime is 3 units. That's good. It's 3 times as big. SW is 2 units. S prime W prime should be 6. 1, 2, 3, 4, 5, 6. So you can even verify. In fact, take a look at our original one, number 16. WY was 1, 2, 3, 4. Half of that is 2. W prime Y prime is just 2. And then Z to Y is 6. Z prime to Y prime is 3. That's also half. So we can just visually verify that our triangle looks half as big in 16, 3 times as large on number 17. All right, we're going to end here. We'll go to number 18 in the next video.